Example 7. In a geometric sequence, the third term is 54 and the sixth term is negative 1458. Determine the values of term 1 and r and list the first three terms of the sequence. Okay, so we know term 3 is equal to 54 and term 6 is equal to negative 1458. We need to know what term 1 is and we need to know what r is. Now, this should look a bit familiar in terms of setup where we would, this is the type of question where we would use a system because we have enough information to plug into the formula twice and solve. And that's exactly what we can do. So there's actually two methods. So we're gonna just actually go over here and work out method 1. So for method 1, that would be using a system. So when we plug into our formula here, we would plug in, we'll do it twice. We'll go and over here, 54 is equal to term 1 times r to the 3 minus 1 is n. And so to simplify that, all we're going to do is say term 1 to r squared. And then our other system, or other equation rather, will be negative 1458 is equal to term 1 times r, and that will be n is 6. So 6 minus 1. So we get negative 1458 is equal to term 1 times r to the 5. Now, up until now, we have been using the elimination method of with our systems. We can't do that here because if we were to do that, these aren't like terms. If we line these up, adding and subtracting isn't going to make sense. So the substitution method, I mean, there is a strategy that we haven't looked at that, but we're not going to learn a new tool when we don't need to because we already use the substitution method. So we're going to use a substitution method and isolate term 1, and then we can substitute it in here. So to isolate term 1, I'm going to divide off the r squared. So term 1 is equal to 54 over r squared. And I'm going to substitute that in then for term 1. So we are going to use the substitution method. Okay, so we got negative 1458 is equal to 54 times r squared times r to the 5. Make sure that you can see that. Okay, so then when we're simplifying this, we have 54. When you're dividing, you subtract exponents. So it's 54 r cubed. Now we can isolate r cubed by dividing off 54. Negative 27 equals r cubed, and we can cube root that. You can cube root a negative number because it's an odd exponent. So r is equal to negative 3. Now you can find term 1. Since we already have term 1 isolated here, I'm going to use this. Otherwise, I can plug it back into either one of the original equations as well. So now we're going to find term 1. So term 1 is equal to 54 over negative 3 squared. So term 1 is equal to 54 over 9, 6. And then this particular question also asks for the first three terms. So if we know term 1, we know 6. The ratio we figured out to be negative 3, so times by negative 3, we get negative 18. Times by negative 3, we get 54. So we've got our three pieces of information for this question. Now, because this system is a little unique with the substitution method, still simple enough to use, there is a bit of a shortcut that works for this method, or sorry, this type of question. So method 2, what we would do is we're going to just sort of visualize our sequence. We got to the third term, so I have nothing in first term. I don't know the second term, but I know the third term is 54. And then I know the sixth term, so then I don't know 4 or 5, but I know 6 is negative 1458. So then I'm going to, so I know this is term 3 and this is term 6. What I can do though is, because I know the spacing between them, is I can write a let statement and say for just this one time, I'm going to let term 1 equal 54, in which case this would be 1, 2, 3, 4. I'd let term 4 equals negative 1458. So if you're going to do this, you really clearly have to say what your new term 1 is, and this. So you have to make sure your setup is very clear. Then we can use this formula and find the final term, we'll look at the number of terms here. So using this information here. And then that would give us to actually this step here rather quickly. So that's a shortcut method that it's significantly less work. So it's definitely an approach you may want to consider. So I encourage you to try this method if you prefer. So then once you find R, you have to find term 1. Of course, term 1 wouldn't be isolated. So maybe I'll show you again here. I would start over. So when I'm starting over for term 1, it must be very clear. I can't use this information anymore, right? Term 1 is not actually 54. We just let that to find the R value. So we go back and we use either information here. I'm going to use the first piece of information. So if I plug in 54, term 1, the R value we found is -3. 3 is the n value when for the 54th term. So 54 equals term 1 times -3 squared. So 54 is equal to term 1 times 9. Divide off the 9 and you get 6 again. So you can get your answers this way. And of course, we don't need to write that out again. You would just redo that question. So it's up to you which method you would like to use, but you do need to very clearly show all your work in the method. So it's very clear that your setup's clear if you choose this method, or here that you're using the formulas and showing the right work.